So in your central nervous system, there is billions of neurons. And we saw different types of neurons. There's kind of, for example, sensory neurons that pick up they're connected to your receptors and they pick up that electrical impulse. And then there is, for example, relay neuron. But these neurons don't actually touch each other. There's a gap between them. And we call this gap the synapse. Now, this is going to be hard to imagine, but each neuron has around about 1,000 possible connections. So there's nearly 1,000 different ways and 1,000 neurons connected to each neuron, meaning there is nearly 100 to 1,000 trillion synapses in your central nervous system. Now, like I said to you before, these neurons are carrying an electrical signal, right? But between the gaps, there's no actual electrical current going through it. What's going through it, however, is a chemical. So one end of the neuron gives a chemical to the other end of the neuron. And then once the chemical is over there, we're going to go through this later on, it turns back into an electrical signal. And the electrical signal travels very quickly through there. Now, the reason why the chemicals diffuse from one end to the other end is because the chemicals build up on this end and it becomes a high concentration. And we know from the fusion, it goes from high concentration to low concentration. So what ends up happening when there's a high concentration over there, it encourages it for a natural process like the fusion to go from the high concentration to the other neuron, which has a low concentration. And once the chemicals end up on this side, they bind over here. And when they bind over there, what it does is it creates an electrical impulse, which then travels through the secondary neuron. Now, we call this chemical a neuron transmitter. After the neurotransmitter has done its job, there are enzymes in the synapse which break down the neurotransmitter, and this prevents, too much chemicals just creating too many unnecessary electrical signals. After it's done its job, you're like, okay, can you go now? And, just end of the story. And these enzymes will break it down. Now, because there's chemicals, if someone takes drugs are chemicals. And what it can do is it could stimulate these neurons. Instead of it happening naturally, if you've got chemicals floating about, what these chemicals could end up doing is diffusing into a secondary neuron when they shouldn't be there. And that can cause a stimuli. Other substances, other drugs can actually block the chemicals from binding to the secondary neuron. And this kind of maybe is for antidepressants or things like that, where people just need to relax and stop feeling these electrical impulses traveling through their body. So like I explained before, some drugs actually mimic the neuron transmitter and fooling the neuron to be activated when it shouldn't be activated. This is why some drugs are actually dangerous. Some drugs are purposely doing this or blocking the neuron transmitter just to act as an antidepressant or so forth. You don't need to go too much into detail about this, but you do need to know what a synapse is. Essentially, it's a gap where chemicals diffuse from one neuron to another neuron. As the chemicals, diffuse to the other neuron, it turns into an electrical impulse. That's a bit of the simplistic way of looking at this.